Welcome to Ask and Learn.
Okay, so in this question, we're being asked to verify that the function satisfies the three hypotheses of Rolle theorems on the given interval, and then we are asked to find the number of c's that satisfy the conclusions of the Rolle theorem. So the function here is f of x equals x cubed minus 2x squared minus 4x plus 2. So here we know that f of x equals x cubed minus 2x squared minus 4x plus 2 is a polynomial. So we know that all polynomials are continuous and also are all differentiable because those are properties of polynomials. So we know automatically that these first two conditions of Rolle's theorems are satisfied. And then the last condition is where the endpoints are equal to each other. And if you actually plug in the values of f of -2, you get -6. And if you plug it in for f of 2, you also get -6. And you can check those values yourself. And that, again, now that they're all satisfied, we can assume that the conclusion is also true. And the conclusion is there is a number c such that there's a number c in the derivative of the function such that it is equal to 0. So we can actually solve for this function because we can find the derivative of f of x, which is a very easy way to do. It's very easy to do because it is a polynomial. So f prime of x is equal to 3x squared minus 4x minus 4. And all we're doing now is asked to find where this function equals 0. And this is a polynomial. So you actually have to factor this. And so there are numerous ways to factor this function. I do it with the x method. You may have your own method. So all you do is multiply the n number. So 3 times -4 gives us -12. And then we take the middle number, which is -4. And then we find two numbers that multiply to give us -12, but add to give us -4. And in this case, it is -6 and +2. And since this is it has a leading coefficient in front of the of our first number in this polynomial, we divide that. We divide that by the leading number, and then this gives us a simplified fraction of -3/1. So that means we take the bottom number, which is 1. So it'll be 1x minus 3 times, and this function is the most simplified fraction, so you just take the bottom number and you put an x in front of it, so basically 3x plus 2 equal to 0. So this is the factored form of our derivative, and now all we do is find where these individual terms equal 0. And they equal 0 when x is equal to 3, because when you solve for this function equals 3, and then you solve for 3x plus 2 equals 3, which gives us, well, it gives us, I believe, -2/3. Oops. So those are our two c or x values that give us where the derivative is equal to 0. And note, this is a very important point about Rolle's theorem. Rolle's theorem only tells us that there is at least one c. So we know that there's at least one c for sure. But in this case, we have more than one c. We have two, in fact. And this is an important point because all Rolle's theorem tells us that there is one. that there was at least one. There could be multiple. There could be 1, 2, 3, 4, and infinitely many. And that is just an important point that should be understood about Rolle's theorem, is that it proves that there's at least one if these conditions are satisfied.